of you got the email today announcing that we were on for tonight? Yes, great. I didn't want anybody thinking that we were going to cancel just for a little thing like we were all in the dark. But the good news is that Albania was not affected by the shut-off. So we're in good shape. Well, I am Eugenie Scott. I'm the president of Bay Area Skeptics. Welcome to the SkepTalk for October. The Bay Area Skeptics sponsors a public lecture every second Thursday of the month here at La Peña Cultural Center. We do encourage you to avail yourself of both the excellent spirits and the wonderful food next door, if such is desirable. Also, La Peña is a nonprofit organization. They very kindly let us meet here without charging us a fee, and so we pass a hat-ish to ask for any donations that you might feel willing to give, and this is divided between us and the I thank you to La Peña. So if I may start this around. Also, if you would like to be informed of Bay Area Skeptics activities and you're not already on our mailing list, please do give us your contact information so that we can let you know about not only upcoming SkepTalks, but also our annual conference with the North Bay and Sacramento area skeptics, SkepTical, which is held in the spring or early summer, and also our activities around Lake Merritt for the Billion Year Walk, which is a spring and summer activity, and our Solano Stroll booth, and other activities that may be coming up. One of which, is, by the way, is the Exploratorium's After Dark program on Thursday, November 7th in the Exploratorium over in San Francisco. They will be having a night, I guess you could call it a skeptical topics, not close enough. It's people who question facts. I'll be giving a presentation, and various skeptics will have a booth where we will be demonstrating how to think about science using the topics of therapeutic touch and also astrology, which for some reason is becoming popular among millennials these days, which is unfathomable. But nonetheless, we will be there, and join us if you would find that interesting. The Bay Area Skeptics is an example of scientific skepticism, a movement, if you will, of people interested in science and critical thinking and testing extraordinary claims. So we will hear about some extraordinary claims tonight involving the field of geology. I'm extremely pleased to introduce my friend and the most recent board member of the Bay Area Skeptics, Stephen Newton. Steve is a professor at the College of Marin in the Department of wrong discipline, geology, the other evolutionary science, as it were. And Steve is a former colleague of mine at the National Center for Science Education, where we worked together for many, many years.
Yeah, almost a decade.
Yeah, I'd have to take off my shoes to count, I think. But Steve was a wonderful coworker and was the major force behind our Grand Canyon raft trip for many, many years. So without further ado, I'm very pleased to introduce Stephen Newton, who will talk about, and you will pardon my language, should students say, or misadventures in earth science education. Steve?
Well, thank you, Jeannie, for that nice introduction to that. And I am Stephen Newton, and I teach geology at College of Marin across the Bay. I'd like to talk today about some of the weird things that I've heard in the almost 2 decades I've been teaching earth sciences. So first a little introduction to myself, and a little bit of an introduction to the scope of the problem, some of the things that are happening with students who are entering into the collegiate environment. What are they bringing with them? Then I'd like to talk about a number of things that I've encountered inside the classroom, things that students have said, and then we'll talk a little bit about stuff that's happening outside the classroom that's also a little weird and detrimental to good education. And then we'll wrap that up with some thoughts about how to break through and make a way forward where we can have better education, better earth science education, better education overall. So, first, a little bit about me. I, as Jeannie said, worked for the National Center for Science Education for about a decade, and I'm currently teaching at College of Marin. Here, you see Jeannie and Josh Rosenau and I in Grand Canyon on one of the many wonderful trips that we took, and we have some veterans of that here as well. The Grand Canyon was something the NCC used to do, and I hope we'll do sometime in the future. It's a wonderful, was a wonderful way for people of like-mindedness to get together and encounter just a beautiful, beautiful place. I have degrees in geology and history, and I hate talking about myself. Enough about me. So let's talk about the problem. So when a person enters a college classroom, and you as a teacher are confronted with that, and I've taught at a variety of colleges around the Bay Area. I've taught at Diablo Valley College, out at Pleasant Hill, at Ohlone College, at Los Positas College in Livermore. Where else have I taught? Ohlone and Fremont. I basically have taught everywhere part-time, and now I'm full-time at College of Marin, and just there. I've encountered a lot of different things that students have kind of brought to the classroom and ask questions about, and I shudder to ask what they don't ask questions about. That's actually kind of worries me even a bit more. We know that a lot of people have the conception that hauntings, spirits, ghosts exist. It's a fairly sort of common thing. This is just a Chapman University survey, the Chapman University Survey of American Fears 2018. Apparently they do this every year. So we know that about 58% of the American public thinks ghosts are real. We know that about the same number thinks Atlantis existed. We know that a good number think aliens either visited in the past or have visited recently. I'm not quite sure what the distinction that they are making there is. That does it really matter? Aliens, UFOs, and we know that a good quarter of people think they can move stuff with their mind, like Luke Skywalker. Nah, I got to work on it. Still not working. And quite a number of people, about 1 in 5 people overall. And so basically, you have a classroom of 100 people, about 20 people in that will solidly believe that Bigfoot is a real creature. And it's maybe that last part that gives rise to this photograph of Teddy Roosevelt machine gunning a Sasquatch while carrying. Wait, I think it's not a photograph. I must have misunderstood the caption. That's just some artist portrayal of that. I'm not quite sure what the radiation belt buckle is going on there with Teddy Roosevelt, but if you're gonna machine gun a Sasquatch, you better be carrying an American flag, goddammit, at the same time. So to think that 1 in 5 students you're encountering thinks that is a real scenario is pretty staggering. Now, another thing that comes up a lot in geology is, of course, dinosaurs and the fossil record. And so let's break down, this is from YouGov, a poll from 2015. Let's break down a little bit of what people think on this. So here's the question. Do you believe, and belief is maybe a little bit of a problematic word, but do you believe that dinosaurs and humans once lived on the planet at the same time? That's the question. So about a quarter of people, ding ding, right answer, definitely not. 18% are like, close but no cigar, probably not, doesn't quite express the reality geologically here. Some say probably, definitely, or not sure. That's not a very good thing either. So as you can see here, it's really only about 1 in 4 people come into the classroom with a proper understanding that humans and dinosaurs are separated by a huge, vast gulf of time. And I should say with an asterisk, because there's always some smart aleck students when I'm talking about this, like, well, what about birds? Okay, right. So technically you can say birds are dinosaurs, but no, not crocodiles, not sharks, but birds certainly are of that lineage. But we're talking the big regular dinosaurs. About a quarter of the American public gets that right. Definitely not living at the same time. About 75% has some degree of getting that wrong. So that's kind of a little frightening. You get a class of 100 students, 75 of them misunderstand this to one degree or another. Which probably explains this photograph of Ronald Reagan riding a velociraptor with shooting a machine gun. And of course, the velocirapter has to be carrying the American flag. Ronald Reagan famously would say, well, everyone knows dinosaurs hate red communism. And that's probably where this comes from. Again, maybe an artistic interpretation, but 75% of the American public believe some variation of this. So, another question to get a sense of the scope of the problem is, which do you think is more likely to be the correct explanation for the origin of humans? That's kind of a touchy subject. How did humans come about? 38%, the account of creation is told in the Bible. 32%, the theory of evolution. Intelligent design, but evolution has happened or they just don't know. So again, ding, 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 just one answer there, but that's about 1/3 of the students coming in have that sort of solid understanding, and that's pretty darn low. Another graph that is a longer-term tracking, this is done by Gallup since the 80s, kind of shows here in the bottom line, humans evolved, but God had no part in the process. That's this line here. 9%, 10%, 15, 19, 22. A little progress. I think we can see that there's some room for not necessarily patting yourself on the back and saying it's all done, but 22% is a leap up from 9%. This competing idea, humans evolved, but God was guiding the process. God created humans in the present form. These sort of are competing with each other up here in the 30s and 40%. So really, in your average freshman class coming into your average college classroom, there's potentially going to be a minority of people who have the true scientific understanding that, again, ding, 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 humans evolved, but God had no part in the process as the correct answer. So it's kind of a hard thing for science educators to overcome when that's what's walking in the door and sitting on your seats as you explain the syllabus. Now, another big scientific issue is, of course, climate change. And this question here is, do you think the severity of recent weather events are the result of climate change, or do these kind of events just happen from time to time? This is maybe not exactly how I want to phrase this question, but nonetheless it gives us something of a handle into understanding. And we see that, let's look at the total here. This is from March 2018. We have 42% saying, it just happens time to time. 39% saying climate change. Now that's shifted in the total quite a lot in just 1 year, from 2018 to 2019. You see also there's a very big political division here. This is Democrats now, 76% results of climate change, 12% just happen time to time. We look at Democrats over here, 64%. So that's a pretty big shift just in 1 year. And if that trend continues, maybe this aspect, at least climate change, will have a better scientific understanding as we move forward over time. Maybe.
Republicans have gone up.
1 point of change here on the just happens from time to time. 2 points on the result of climate change. I'm not sure what to make of that. It's a pretty small variation, but it's something, I guess. Now, another thing that people coming into the classroom may have misconceptions about is astrology. About 30%, about a third of students are going to believe that signs and the stars and some sort of influence that has some effect on their life. About a third, again, the same number, are going to believe in reincarnation. And some people believe that psychics are telling the future. This one I found particularly interesting. Spiritual energy is located in physical objects like mountains, trees, crystals. A pretty big number, more than who accept astrology. 42% are thinking crystals, mountains, forests have some sort of special magical thing to them, which is very problematic when you are, as an earth scientist, teaching about mountains, teaching about crystals, all these sorts of things. I go at some length into why this isn't true, and I'm sure there are students who are just like, that guy. He hasn't felt the crystal chakra yet. I can only get through to some of them on that, but I sort of assume coming into it that a lot of students are going to have these misconceptions. So maybe even of all these sort of polls showing different scientific misunderstandings, this is the one that I find the most worrisome. It's the most general. And this is the question: would you generally trust scientists to tell the truth or not? This is basically trust in scientists. And this color here is completely or a lot. This color is a moderate amount. This color is a little or not at all. So if we look at the total numbers here, the correct answer, ding, 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 is completely or a lot. Only about only about 3 out of 10, 30% are holding that view. And a pretty significant number here, 71%, has some sort of, they mostly don't tell the truth, or sometimes they don't tell the truth, some sort of fundamental distrust of scientists and the scientific process, some sort of feeling that something wrong with the way science happens. And note that this is not as politically bifurcated as some of the other polls. Notice the Democrats here have a pretty solid lump here on that, can't trust scientists or can only trust them a little bit. It's not really that different from the Republicans, and that stuff is even worrisome. That there's a lot of people who seem to think that scientists are, thousands of PhD researchers and all these thousands of universities are all conspiring to have some sort of improvement in the environment or something. What a crazy idea. They've obviously never attended a university faculty meeting. Herding cats is too much of it doesn't quite tell the tale of trying to get academics to agree, much less conspire on something. So I think that is maybe, we could say, the biggest problem. So let's delve down to a little bit some of the things I've seen in the classroom here. And the thing that comes to my mind first off here is the crystal issue. So that idea, 42% think crystals, mountains have some sort of special feature, special energy, that they're not just atoms that are arranged in very regular, orderly structures with cleavage and hardness and density, but that there's something else. So here's kind of a typical thing that if you Google for this, you'll bring up. Aventurine increases intuition, promotes the chances of money. Why? Because it's green? Is that why? Jasper keeps other people's negativity off of you. That ain't working for me. Rose quartz attracts and keeps love into your life. Now, I've been around rose quartz for decades, a lot of it, and I think never once has Jessica Chastain walked into my classroom and professed love. So clearly I'm not giving enough rose quartz going on there. Sodalite promotes peaceful sleep. Well, there's something that promotes peaceful sleep, but it's not blue. I don't know what that's about. Yeah.
Is the idea just keep it around you? I mean, you certainly don't eat them, so you just keep it next to you.
Yeah, some sort of proximity thing. I think that must be sort of a key thing in that you have to have it, maybe have it in your pocket, have it close to you, because it all exists. And if just the existence of it in the world did something, then it wouldn't matter whether or not you bought their product. And of course, they're all wanting you to buy their product. Here's one that is maybe even a little bit worse because it's talking about children. It's bad enough when adults are being separated from their money and from their understanding of the world, but this is something promoted towards children. So here we see aquamarine for courage and protection. And I would just like to, go up to the kids who are holding their aquamarine and saying, courage and protection, not going to work. That bully is going to take your school money tomorrow too. Sorry. Nothing can protect you. Or smoky quartz protects from nightmares and irrational fears. You look at the kid with the smoky quartz and say, maybe your fears aren't so irrational. Maybe, in fact, you're not paranoid enough. Maybe things are going to be worse than you think. And here we have rose quartz to ease feelings of abandonment. I just have to pat the kid on the shoulder and say, Mommy and Daddy have abandoned you. Not because of rose quartz. You shouldn't have cried so much. No, I wouldn't do that. But you can see how a kid looking at this could really feel that, maybe there's something wrong with me, that I didn't have enough rose quartz around, I didn't have any aquamarine around. And in that sense, it almost just makes me angry that people would address children in this pseudoscientific way. So So in Googling around for this and preparing for this, I found quite a lot of crystal info on this website, Goop. Are you all familiar with that? Yes. This is a website run by Gwyneth Paltrow, which is the answer to this question. And Gwyneth Paltrow is making a lot of money by selling a lot of crystal stuff. And this is just highlights of one page on Goop. There's lots of other stuff on this Goop website, which is selling all sorts of things. This is 8 crystals for better energy. And this is an interview with Colleen McCain, a certified shamanic energy medicine practitioner. Certified? How do you get certified in that? Yeah, there's some certification going on. I don't think it has to do with any medical sense. And this interview with this woman is talking about both the scientific and the more mystical aspects of crystals, although noting that her previous career before doing this for Goop was of being a fashion stylist. Doesn't mention whether she's taking classes in mineralogy, which is what you sort of think of as a basis for understanding anything about crystals, or physics, or chemistry, talking about the bonds. No, none of that. Just certified in something to sell you very expensive things. How expensive, you ask? Well, let's look at some of the offerings on Goop. Here is a water bottle with an amethyst crystal in it, a mere $84. If you call now, we have a special deal and charge you $100 for it, even though it only said 84. And here's a rose crystal straw. It's a metal straw, so it is a little environmental good that way. But this rose crystal straw has rose quartz on it, and I guess you're supposed to stick that into your drink and suck it through, and it does something, I don't know, for $68, so that's relatively cheap. That's the kind of parting fools with their money that happens on Goop. And really, you ought to scan that site. It's a piece of work. It's not just the crystal section. It's
certified?
Yes, are they certified? That's the question to ask. But available from goop.com right now if you are so interested. So, if you search for crystal energy, you'll come up with innumerable things like this, which lists different types of rocks and minerals and lists what they do. Quartz is for clarity, lapis lazuli is for communication, black obsidian is for stability. Where are they making this up from? It really it just seems completely fabricated. And from a geologist point of view, what I like to do in the classroom on this is when people are talking about the various things that these have, and I get a lot of questions from time to time with students. Even sometimes I assign them to do presentations about a particular mineral, and this is the kind of thing that comes in their presentation. I go, that's very disconcerting to me in the classroom. But one thing I want to emphasize is these seem like different things. They're not. They're actually all the same thing. So, rose quartz, silica, SiO2. Obsidian, mostly silica, maybe a few other things. Amethyst, silica. Citrine, silica. Quartz, silica. Jasper, silica. Carnelian, silica. All these things which are purported to have these different properties, chemically, when you break them down, are basically just the same damn thing with a slightly different color. So, that's something I think in my classes I try and emphasize, try and get to students that you think these are different things. Let's look a little deeper into what they actually are. And here's a more reasonable chart. Amethyst doesn't do shit. Lapis lazuli doesn't do shit. Obsidian doesn't do shit. Quartz doesn't do shit. That I wholeheartedly endorse. Now I wondered sometimes whether or not it's all Mr. Scott's fault. Because if you're a Star Trek fan, you know that whenever something gets bad, it's the dilithium crystals, Captain, they're destabilizing, they're powering the ship. So I know this may be shattering that there's something unscientific in Star Trek. I know they show the idea of people just being separated into their molecules and beamed in some sort of quantum state and then reassembled as if nothing happened. It's a little unscientific. But in this show, I'm talking the old school Star Trek, they would sometimes bring up a crystal like this and say, that crystal is what is powering the Starship Enterprise. It's a dilithium crystal. I don't know if by lithium, the element, gets any special thing on this, but one thing I try and emphasize in my classes is talking about energy levels. And that if we were to take dilithium or any sort of substance and really heat it up, we could turn it into a gas. It would have a lot of energy there. It could burn you. It could heat something else up. We lower that energy. We get to a liquid. We lower it more. We solidify it. This state here, being crystallized, is actually the lowest energy state possible. You can't get any less energy than being in a crystal. Does it have energy? I guess that you could say that the bonds between the atoms have a certain measurable energy, but it's not like you can stick up electrodes to it and power a starship. That just does not work. So I wonder whether Star Trek has contributed to this, but maybe we shouldn't blame Star Trek too much. So there's a nice quote from Leon Trotsky on this, which sort of focuses my mind to think that the way people are thinking of these crystals is some sort of magical amulet. I mean, it's straight magic. What Trotsky wrote was this: there lives alongside the 20th century the 13th. 100 million people use electricity and still believe in the magic powers of signs and exorcisms. Aviators pilot miraculous mechanisms created by man's genius, and they still wear amulets on their sweaters. So I wouldn't normally agree with Leon Trotsky about anything, but on this point, I think he nailed it. And, hung out with Frida Kahlo. That's kind of cool. This was, of course, before his second career as the spokesperson for Kentucky Fried Chicken. Put him in a white suit. That's Colonel Sanders, I hate to tell you. Anyway, what are you doing with that mountaineering axe? Oh, nothing. Too soon? So that's crystals. Let's talk a little bit about another thing that I've encountered a number of times in the classroom, where I talk a lot about plate tectonics. That's a huge part. It's kind of the foundational theory of geology. A number of times I've had students write essays that do actually very good jobs of explaining what I want them to know about plate tectonics, but I'll see a little asterisk by it or some sort of little note saying, although, Professor, I've told you what you wanted me to say, I really don't think this is true. I really don't think this can happen. And that's always makes me staggered a little bit when I actually see that on a test. The idea that I present a lot of evidence for the existence of this, I talk about how it developed, talk about how it explains so much of the world, and yet even still that's not quite getting through to people. This may have something to do with students who are thinking the Earth isn't quite old enough for this to have happened, or that the continents have always been in this shape and we're misunderstanding their movement. But it's a little disconcerting that even something as fundamental as plate tectonics in geology, not every student who walks through the classroom is on board with. Although I've had some, on test write this, I shudder to think how many have just written what I want them to say and not called themselves out like that. It must be a much higher number, and I really sort of don't have an easy explanation or an easy idea for how to get around that. I mean, it's such a well-developed theory, so much evidence, kind of like the theory of evolution, right? And yet there's a certain percentage that you're just not going to reach in at least one class. Another thing that's come up from time to time is hollow Earth. Now, this is a very strange idea and has a lot of different permutations, one of which is that at the North Pole, or the North and South Pole, this is what it looks like. There's a big hole that goes down into another Earth inside the planet, and another sun, and dinosaurs, and it really seems to be mixed up, sort of a Jules Verne thing. It's quite bizarre, and often aliens get thrown into the mix. Now, I don't have quite students raise their hand and say, well, I think the Earth is hollow and that there are dinosaurs living in there, but they do misunderstand a lot of things about the nature of the interior of the Earth. I show pictures like this, the Nika mountain crystals in Mexico, and students have asked me, well, I guess that's what most of the down below the ground is like, right? These pockets of crystals must be everywhere. This is the inside of the Earth, and I have to kind of let them down and say, it's one spot inside the Earth, but this is extremely rare and not typical. There's not somewhere under the ground underneath your feet hollow caverns filled with giant crystals. This is one exceptional place, and I also have to point out to them, this cave in Nika Mountain in Mexico is usually completely filled with really hot water. So to get people in there to take photographs, it has to be pumped dry. And then as soon as they stop pumping, it fills back up with groundwater. So this is not a place that you can go and venture, and this doesn't continue onto other spots of the underneath. I think sometimes students think there are cave systems that connect to each other all throughout the continents, and if you just break through one, you can get into much bigger avenues of the world that are exposed like this. And I have to kind of let them down and say, well, there are spots in the world where there are caves, usually on limestone and usually not on anything else, and they don't really connect to each other very well. It's kind of disappointing. The Earth is not really hollow. There's not really a world underneath there. There's just pockets from time to time that you can see. Now, another thing that I consistently find students having trouble with is the idea of groundwater. Now, groundwater, of course, comes up a lot in geology because it's where pollution and is moving throughout the subsurface. It's where water for wells and for agriculture is moving. And I try and give the analogy that, imagine a sponge, a wet sponge, and it's slowly seeping from one side to the next. That doesn't seem very satisfying. I keep having students say, well, there must be some sort of river, some sort of opening, like a big hollow tube. And I was like, nah, it's more like a sponge. It's just sort of wet mud, and very slowly it moves from point A to point B downhill. Really, we're talking in some cases meters per year, really slowly. And that's something that I found a lot of students struggle with accepting. They kind of want to think that there's more going on underneath the ground, that there's more hollow cavities filled with giant crystals. It's a nice thought. I have to let them know that it's not really true. Talk about earthquake prediction. I get asked that all the time. A lot of people come to the classroom with the assumption that there's something about earthquake prediction that scientists aren't telling the public. That we have some way of knowing an earthquake is about to happen that we don't use for our papers. For some reason, we don't like puppies. Must be it. It's like, I guess the idea here is animals predicting earthquakes start something like this. You see your dog coming up to you, your dog starts going, or barking, and say, Mr. Barkley, what is it? An earthquake is coming. What's that, a P wave coming? Oh no, the S wave is coming. Oh, Mr. Barkley, you knew it was going to happen. Animals have no special sense of telling earthquakes are about to happen. There's no correlation between animal behavior and earthquakes, although I think a lot of people have this idea that somehow you can look at your cat, and your cat is running around your living room playing with imaginary things, and that cat's behaving strangely, and then an earthquake happens. It's like, aha, the cat knew the quake was about to happen. You might step back and ask, did the cat does it usually run around the front room and do these weird things? Oh yeah, every night. Like, there you go. Just because the cat happened to be behaving strangely and then suddenly an earthquake happened doesn't mean the cat has some special knowledge that seismographs don't. Chemtrails. Oh, that comes up a surprising amount. And the idea here is that there's some chemical, usually people say a mind control chemical, although sometimes there's also a climate change thing. They're trying to alter the climate with this. That's left behind by these condensation trails by airplanes. Now you can explain the physics that it's really pretty straightforward. We create this area of low pressure. We get as a jet is passing, these clouds that form in that area of low pressure temporarily. I mean, there's easy explanations for what's going on here that don't involve any sort of chemical. And if you think about it, if you wanted to disperse chemicals to the population, wouldn't you like put them in potato chips? Start handing out bags of that free. We get so dispersed through the air like this. And what would these mind control chemicals be? That maybe sort of comes into the idea that people have that there's something like a truth serum. You inject someone with a truth serum and they'll have to tell you the truth. No, that doesn't really exist. So the chemtrails is something that comes up quite often. And I don't know quite how to deal with that. I try and be respectful, but inside of me, I'm just sort of wanting to say, why don't you give that a little thought? period.
I have a question.
Yeah.
One of the arguments I've heard is like, some airplanes, the line will go away instantly and some stay. And that's the argument that the ones they shouldn't be staying. The oxygen should go away after an airplane flies. The line only stays for so long. Sometimes there's a long line staying there, and sometimes there's not. And that's just one thought.
Right. Well, there are certain conditions of temperature that make this more likely to form. What you're seeing, I think, with the lines suddenly disappearing is a change in temperature like that, just different temperature masses. Sometimes airplanes fly and don't produce these at all. You need a certain amount of moisture in the air for this condensation to happen in the first place. So does the sudden stop look like they've shut a valve in the plane? They've turned it off? I mean, it's really pretty simple physics of how this happens. And again, if you want to poison the population, there are much more efficient ways to do that. This disperses it. Yeah, exactly. Drinking water. I mean, that could be another avenue if there were mind control chemicals.
On the tap water, on the floor, and the chlorine?
No, I don't. But anyway, but I've encountered people just sort of in classrooms. And I've taught all around the Bay Area. I'm not being specific to any particular school, but bringing up this idea that there is somehow a poisoning from the sky. And it's true, there is. Carbon dioxide, but that climate change is a whole other thing. All right, now something that always comes up, a surprising amount in my classes, is when I'm talking about environmental issues. For instance, I have a big segment talking about the lead poisoning of kids in Flint, Michigan. Sometimes it's said, well, why don't the authorities just treat them homeopathically? And I have to kind of stop in the classroom and assemble my patients and explain that actually won't do anything. So what is this? What is this homeopathy? Well, it's a very interesting idea, a very strange idea that seems very embedded in a lot of people's thinking. And the basic idea is this. You take some substance. We start off here with this, the original source, the tincture, the extract. And you take a drop of that and you add it with 99 other drops. And then that mixture you shake up, and then you do that again. And this process is called, if I can pronounce this correctly, potentization. You are increasing the potential. That's the idea of it. As you go through these steps of getting smaller and smaller amounts of it, some sort of magical thing from that original tincture, whatever that was, gets diluted and becomes more powerful, more magical over time. That's the basic idea of homeopathy, that you have something that's very diluted, and somehow that exposure is going to solve the problem. So I guess with the case of Flint, Michigan, what you'd want to do would be take an amount of lead that's dissolved in water and then dilute that. I don't want to drink any more lead than possible. I mean, that makes no sense at all. And in this case, it's even worse. Homeopathic cream for hemorrhoids, which brings the question to my mind, what did they use as the original extract? Because there is no amount of dilution in the world that would make me want to have in contact with that, if that's how they went about that. So the idea here in homeopathy is basically the more you dilute something, the more potent it becomes. Which you have to just sort of think, I took all these years of chemistry and this is what I'm dealing with. This is not how this works. This is not how any of this works. This is not how chemistry happens. And there's something just really fundamental about many students' understanding of this basic chemistry that is just wrong in this sense, and that needs to be corrected in a respectful way. You don't want to mock any students, but when this comes up, especially in regards to things such as lead or mercury, arsenic in drinking water, I often get these comments, well, you should just treat them homeopathically, that will solve it. Like, no, yeah, I wish it were so simple. So the idea of homeopathy actually comes back to a much older idea that is like cures like. That if you're suffering from something, a little bit more of it will help you. And there's an old phrase, which you might remember from The Shining, what you want to drink is the hair of the dog that bit you. In other words, if you're drunk, if you've had too much whiskey, and you wake up and you have a terrible headache, what you want to do is have a little more whiskey. because it'll kind of ease yourself off it. Now that is completely not what you want to do. Any more whiskey will just make your hangover worse. But it's sort of an old idea that the hair of the dog that bit you will cure your hangover, which, as you can see, actually didn't work out that well for him. So another thing that, of course, comes up is evolution. And I haven't, in my experience, really had students who are just full frontal when we're talking about fossils and the evolutionary record, just saying this isn't happening. But I certainly have had a number of students who raise their hand and sort of timidly will ask me questions like, well, isn't DNA just information? Where did that information come from? And I almost feel a moment of pity for them, because I have no idea my background with NCSE and my deep background in this, and I don't want to embarrass them too much. But I get you asking, well, so when you say information, are you talking Shannon information, Kolmogorov information? Which is it? If you can't define those, how can you even talk about information to begin with? Like, well, they're stunned at that point. They have no idea where I just went with that. But this idea that there's information in DNA and biological systems, and somehow that information had to be intelligently designed, is something I find a lot of students are coming to the classroom with. Again, evolution, remember those earlier charts, is not widely accepted. I mean, it's kind of a minority who come into the classroom, and maybe some of them don't even realize this idea of information theory as being a non-scientific attack on evolution. But I think those who are approaching that think they're being clever and sly, and as with crystals and homeopathy, just don't have the scientific understanding of this. Climate change. So quite frequently I encounter students who do not like what I'm saying about climate change. And there's lots of reasons that could be behind that. I think one of them is just perhaps fear. It's a much easier thing to hypothesize that all that scientists are saying, all the sort of apocalyptic end of the world thing, is mistaken. It's overblown. It's not really going to be that bad. And I kind of understand that sentiment. I mean, I wish the understanding of climate change turns out to be wrong and it's not going to be such a catastrophic thing. I'm sure that that's not the case, that it is going to be more catastrophic than we even imagine. But I can understand the impulse to want to say this is heading towards us like a bunch of trucks, and there's not much we can do to stop it. Although, as we learned in Tiananmen Square, sometimes even one person can stop a whole bunch of tanks coming at us. Now, I'm going to talk about a few things outside of the classroom. And for those of you familiar with Harry Potter, you'll recognize this character here. Let me get a show of hands. How many people have taught at some place? Have been in a classroom somewhere? Okay, so the character of Dolores Umbridge, and that sort of type of administrator, maybe someone you have recognized. A lot of people, when they come across Harry Potter and this particular character, say, oh, I know her. I know that kind of person. Some of the things that come up with this, some of the things that teachers are facing outside of the classroom really involve, well, I want to focus on three things here for this. And one of them is a pervasive culture of micromanagement that's kind of unique to education compared to other professions. I want to talk about that. I also want to talk about the magical idea of learning objectives. This is an idea that just putting something on the board, stating where you're going to go, somehow fixes the problems of education. And lastly, I want to poke a few holes in something called Bloom's taxonomy, which is very much an accepted wisdom among many educational managers, but teachers know doesn't actually work. So, imagine in a hospital that the professionals who have trained to be surgeons, who have gone through all this education, and are actually working on a patient, are about to cut the patient when a hospital administrator comes over who hasn't scrubbed in and says, no, don't cut him like that. We're going to cut him another way from now on. Like, excuse me, do you have a degree as a doctor? Are you board certified? No, but I'm the manager. I'm going to tell you how to cut that patient this way. That would seem ridiculous in a hospital environment. It would seem ridiculous in the law if, as a lawyer is about to present an opening case, some manager comes over and says, actually, I want you to file a writ for this other thing. You know, we're just not a lawyer trying to interfere with that. We wouldn't accept that in the profession of law or profession of medicine. But somehow in the profession of teaching, every single aspect of what a teacher does is subject to manipulation, coercion, and constant change on a whole broad swath of things that are really detrimental to the classroom environment. And I think a lot of this has to do with misogyny. The profession of teaching has, for a long time, been thought of as a traditionally female profession. And I think there's a misogynistic, a certain patriarchal view that, oh, you don't really know what you're talking about. We're going to come in and tell you how to do your class, and we're going to tell you what kind of tests to give. And I think when we approach it that way, when we really see the misogyny behind it, we realize that as a professional, a teacher will have a bachelor's degree, will often have a master's degree, will often have a teaching credential on top of that. So, you know, we're talking 2-3 years past the bachelor's degree. How long does it take to get a JD if you're a lawyer? 3 years. So it's kind of comparable in terms of the amount of education. Lawyers are not having micromanagers coming in the middle of a courtroom and telling them, you know, to do something differently. Teachers are subjected to that daily. I think it's a very corrosive thing and ultimately doesn't make sense for the classroom. Another thing that is encountered all the time by teachers, the K-12 and in the collegiate environment, is the idea of learning objectives. And here's the sort of magical word idea of this. If you clearly state accessible goals that can be tested, if you clearly state the expected outcomes, then suddenly students will learn better. Suddenly that will remove the deficits that students might have in this. And I think that idea is just without foundation. It's an idea that comes from a kind of a mechanistic view of education. Note this diagram here, which is supportive of this idea. Learning objectives as a gear, turning into learning activities, turning into assessments. The language here is interesting. It's always learning objective, learning activity. Why don't you say it's the thing you're doing in class? It's the test you're giving them. It's what you're trying to do. In a way, it's a little bit of a shibboleth, kind of a phrase that people who have accepted, who have submitted to this idea, are forced to use. If you're talking about learning objectives and you voluntarily use that language, this is why I have it in quotes, you're giving into this idea that this is how education should happen. And I think this is just as pseudoscientific as saying that crystals have some special power. And the mechanized diagram here, I think, has a kind of unintentional irony. Think on this. Is this what we want a classroom to look like? I don't think anyone would agree that a factory floor assembling gears is how we really should do education. Some classes might look like that, but what we really want classes to look like, what we really want the educational environment to be, should look more like this. Socrates, a small group, someone posing questions, not necessarily always the teacher, posing questions and then changing those questions in response to what the students are responding to, basically trying to get people to think. Socrates would say, I can't teach anybody anything. I can only make them think by asking them challenging questions. That, I think, is a much better model for education, and that's not really happening. Socrates was a teacher right up until his last moments. Here you see him about to take the hemlock cup. Gathering around, talking to people, the dialogue where he's taking the hemlock, he's arguing that the soul is going to continue on and trying to offer proofs from that, even as he's accepting his execution. That's a teacher, right to the end. Let's talk a little bit about Bloom's taxonomy. So something I've encountered in my educational experience is almost a constant regulation on the words that one should use in syllabi, in course outlines. And what I get told is, I like what you wrote, Steve, but you need to change it to the language of Bloom's taxonomy. So what the hell is this? Bloom's taxonomy is what you can see here in this diagram, kind of a pyramid of ideas. On the very bottom, we have remembering. On the very top, we have creating. And it's the idea that there's a cognitive domain between these different words. remembering, understanding, applying, analyzing, evaluating, creating. And as we go towards the top, it's better for learning. As we go towards the top, that's what students should be doing. And what I typically get is feedback in the classroom, or rather feedback from outlines and such that'll say, Steve, too much of what you're doing is low on the cognitive domains and booms. You need to bring it up towards the top of the pyramid. And I just have to do, the Picard face plant, just like, you don't have any idea what you're talking about, do you? No, they don't have any idea what Bloom is actually talking about in this. The idea that somehow using slightly different words in the language that you use in the classroom, slightly different words in your course syllabi, slightly different words in your course outlines, is somehow going to magically make education happen is, I think, as pseudoscientific of an idea as imagining Bigfoot is walking around or that crystals have special energy. When you're talking about defining something as opposed to developing something, talking about interpreting something as opposed to predicting something or summarizing something, these are just pretty interchangeable words. And the thinking from a lot of educational micromanagement is that don't use the left. If you see those words, strike them out and replace them with words from the right side, and that will make everything okay. And that's just magical thinking. Now, whenever this comes up in a meeting where an administrator or someone else is recommending, saying, Steve, you have to use these words, there's always three questions I like to throw at them. Say, so you say I should change all this according to this other way of thinking, this Bloom's taxonomy. You must know a lot about it. You must know what it is. So answer me this. What was Bloom's first name? What was the name of the book that he's most known for? And bonus point, when was it published? And lastly, what, according to Bloom, is the very foundation of learning? Any takers? Anybody know? Yeah, that's the kind of the lack of response I get as well when I push back on this in outside the classroom meetings. People are kind of stunned. They're like, well, I don't know Bloom's first name. I don't know the name of the book. I don't know what he says is the foundation of learning. I'll tell you. First name was Benjamin. The book for which he's most widely known, which, by the way, he didn't write, he just edited, is called The Taxonomy of Educational Objectives, published in 1956. I don't know about you, I like to have my neuroscientific and cognitive thinking somewhere more advanced in the Eisenhower era. And what he says, and this or what is said in this book, is that pyramid, the foundation of it is memorization. It's not that it's the lowest, worst level. It's that it's the necessary foundation for everything that comes above it. You can't do the higher levels without having first the base well established. And so, although I hear all this pushback outside of the classroom, don't make your students memorize. They can just look it up on Google. Yeah, well, with the power out and the internet out, I'm sure there's a lot of people who have been experiencing like, oh, I can't look something up on Google. Oh, maybe I should have actually learned that. That foundation of learning through memorization, through this sort of what was denigrated, really, according to Bloom, is what you need to do all the rest. And they haven't read the book, and they don't really understand it. This is pervasive both in the K-12 environment and in the collegiate environment. So, in terms of these magic words, analyze versus apply versus understand, this is all just made up. This is all without any real foundation behind it other than this one guy said it back in the 50s. And there have been some revisions since then. But I think it's really a short-sighted attempt to make education happen through magic. And the truth is there are no shortcuts. There really are no tricks. Education is hard. Education, as Aristotle would say, hurts. Aristotle would say learning is not a joke. You cannot learn without pain. And in the education you've had, you probably appreciate there's physical pain. Pain in your butt. Pain in your legs from sitting so long studying. There's pain in your eyes from being 2 in the morning and you gotta keep reading. There's pain in missing out going out with your friends, not going out to movies, denying yourself. This is what education is about. And if we just think, if we just shuffle the words slightly differently, then it'll all be okay, is as magical thinking as imagining that crystals have some sort of special power. So how do we go forward from this? Well, I think something to keep in mind with all these aspects, both inside the classroom and outside the classroom, is to be respectful. If you as a teacher attack attack a student. Say, homeopathy, how can you possibly believe that? That is never an approach I would take, because it's going to be counterproductive. It might feel in the moment like what you want to do, but you got to be mature and hold back. Be respectful, even of students who are saying chemtrails are happening and Bigfoot is real and evolution isn't true, because only by being respectful and trying to correct them, perhaps through a Socratic method of asking them challenging questions, only then is there really the hope that they might be led towards more skeptical thinking. I think also inculcating everything one does in the principles of skepticism, demanding evidence for every claim, not taking anything on authority, is particularly important. I like to say often in the classroom, don't trust me. I don't know what I'm talking about. And I hope that's somewhat eye-opening to students who are expecting the sage on the stage and who knows everything, and say, I don't know everything. In fact, I know a lot of things that actually aren't true and I don't realize it. So you got to challenge me. You got to not accept what I say. And I hope that's a lesson that students can get through that lasts them throughout their careers and elsewhere. And also, I think we want to emphasize the sense that reality is interesting enough. Reality is so fascinating. Rocks and places are just so amazing. We don't need Bigfoot. We don't need UFOs or Atlantis. The world as it is, the desert of the real, is enough for us to be amazed by. And so, we're going to conclude then on that point, and I hope it'll get me kicked out of an NBA game, but free Hong Kong. All right, well, thank you very much. So I think we got time for some questions.
I do believe we do. And this microphone works. Let's see, did we have a second microphone, or I will sprint. All right. If there are any questions for Steve, I will pass the microphone. And please do use the microphone because we're going to be taping this and we're cutting his slides and it'll be available online.
Yeah, I find like a lot of when I talk to people about climate change and evolution, that one of the problems you come up against again and again is the difference between human and generational time and geological and cosmological time. Mm-hmm. It is really, someone will show, well, my grandpa wasn't a monkey, so how can I be descended from monkeys? I mean, who is descended? Right. Even the evolutionists show that. And did your grandpa look like a monkey? Mm-hmm. But it's like people have no concept really of what even 1,000 years is versus 1,000,000 years versus hundreds of millions of years. So what I think is that we really need to teach more and see more of those graphs that show really how long this is. That evolution didn't just happen yesterday. It isn't just like that. Some things do evolve fast. You can change things. You see it happen. But that the evolution of the human species was a hugely long process, and it isn't even really capable for the human mind to comprehend that.
Mm-hmm. Yeah, I think it's a very good point. I mean, there is this, especially in geology and the earth sciences, this breadth of time that is really not something you can get your head around. I mean, I try and say, for instance, that we all have a common ancestor very recently. We have a common ancestor in Eastern Africa, this mitochondrial leaf about 170,000 years ago. I'll try and say to students, that's not that long ago. You just go great, and you can work it out that many generations. You could mathematically figure out how many generations back it goes till we all have a common grandmother. I mean, and that's, I'm not sure that really gets through because it's a lot of grades, but I try and sort of spell that out. Like, if this back, and it's not that far and that's only 170,000 years ago. Of course, that's very different if we're talking millions of years. Again, I can see the dinosaur thing being part of that. 66 million years ago, the dinosaurs get wiped out. It's hard to comprehend that gulf of time.
Yeah, that's one reason why the Bay Area Skeptics has a annual billion-year walk around Lake Merritt, which is about 5 kilometers, 3.1 miles. And to get people to realize that at that scale, just the thickness of a sheet of paper is over 20 years. And the dinosaurs are actually pretty close to the end of that billion-year walk.
Absolutely, and you can actually see the logo of it right here. Is the Stegosaurus being level on. So when is the billion-year walk happening again?
Probably in late April.
Okay. And put that on your calendar around Lake Marin.
Thanks for what you said. I taught for many years here in Oakland and San Diego. Oakland has an advantage of, at least in things like earth science, which is a lot of inference stuff. And for younger kids, it's hard to understand the difference between inference and a guess. And you have to. And because Oakland uses kits such as the FOSS kits, which puts hands-on things into their laps, that helps. But in all the schools I've taught, it's always been just a war to get, and I taught earth science, that's why I taught, it's just been a war to get them to real places. You
mean on field trips?
Fault traces, volcanoes. We're in a wonderful place for people to examine and explore things for real. When we take our kids from San Diego or Baycross School, we take them every year to the church beds up by Huckleberry.
Oh, yeah.
And we talk about how long it takes. And then we go back and we start laying out, dust in piles and stuff. And they begin to get kind of, I think, an idea of how long things take. But I think the thing we're facing, or at least I felt always facing, is that there's never enough money and the energy is such that they see field trips as a distraction. And I don't think they are at all.
Well, look, can I ask, were you teaching before 1978 and then after 1978?
No, I taught after. I was a welder.
Oh, okay. Well, I remember being a student in California public schools before 1978, and then afterwards. And what happened in that year? Prop 13. That changed everything in terms of field trips for students. There were a lot more field trips when I was in the younger part of my education, and then that just came to a crashing halt. And let's try and do a field trip, but we'll have to have a bake sale to raise money for it. That's when that sort of thing came out.
Can you explain what Prop 13 is?
Yeah, so Prop 13 is a limitation on property taxes. It freezes property taxes at the level when you buy the house. My mother bought her house in Vallejo in the early 1970s, so I think she pays in 1 year of property taxes much less than I pay in 1 month. So it creates these great disparities because she's locked in on the original time and purpose. And of course, since our system of funding schools is insane, the sort of local funding is the primary. I mean, the primary thing for whether or not you're going to succeed at school is, of course, your zip code. That's the biggest filter, which it just makes no sense at all. I mean, in terms of wasted talent and such. So anyway, the funding for the field trips I found really collapsed after Prop 13. I remember it. It was like, oh, we're not going there this year like we did last year. We're not going anywhere ever again. That's kind of how it's been since then.
Yeah. I'm really interested in your experience dealing with students that are resisting, say, for example, evolution.
Yeah.
I mean, I constantly meet people and have discussions with them and am amazed at what they believe and, their ideas. My question really is, your job is to sort of direct someone to believe in evolution, I guess, to understand.
Or to accept it.
Yeah, to understand what it's based on and so I'm really intrigued to just to ask you, what are your techniques? You've said to be respectful, and of course that kind of goes without saying, but
I wouldn't say that necessarily goes without saying.
What would be your best advice to all of us?
I think my best advice in terms of teaching evolution in specific, or any sort of controversial thing, if you have a class that's full of what you sense are a lot of people who don't accept climate change, or teaching evolution, would be to break it down to a very granular level. I mean, something that I try and do in introducing the main idea is asking, is everyone identical? Does everyone look exactly the same? And well, of course not. So there's variations in height, in weight, in hair color, and all sorts of things. Then you ask, well, are some of those variations inherited, or are some of them acquired? I eat too much, that's why I'm bigger, but that also my hair color is not something that I can adjust. It's something that's locked into the gene. So what is locked in, what is hereditary and what is sort of acquired can be a distinction to make. And so when you realize that people don't look exactly the same, and that some of that is hereditary and some of that can be passed on. I think that's a way to sort of start it. Even people who are very resistant to the ideas of evolution, who really, for perhaps a religious reason, are just don't want to accept it, they kind of have to accept that not everyone in the classroom looks exactly the same. I mean, when you break it down to that sort of question, they kind of have to nod and say, yeah, that part's true.
So you're recommending the dialogue?
Yes, I am. I'm recommending this guy. Engaging with challenging questions, I think, is the way to get it done in the classroom.
Poke a hole, challenge them to say, how do you answer this question with your theory? If the Earth is flat, how do you explain the Coriolis?
Yeah, right. That's a good. The Coriolis effect. I have a really difficult time explaining the Coriolis effect, even with students who accept everything else. I'm sort of explaining this, and so then like the thing veers to the right, and then the other hemisphere veers to the left, and they're just like, you're just making that up. That's not true.
Being from Australia, I can assure you it's true.
Yes, well, it is absolutely. But in terms of talking about oceanic circulation patterns or such, that comes up, and students are just like shaking their head, like, this can't be real. The Coriolis effect can't be real, and that's good. I mean, if you have a student having the reaction that this is not right, the teacher's on the right track, I think.
If I may interject an appropriate comment for an Australian. The head of the International Flat Earth Research Society was a man named Charles K. Johnson, who died in like 2001. So in the 21st century, there was a serious flat earther, and now there's more, but nonetheless. His wife was Australian, and she signed an affidavit that she's never hung by her feet, and this man isn't.
Never? Not even been practicing acrobatics?
Well, because she's on the underside of the
Oh, yes. Okay.
Steve, do you have any evidence about changing students' minds about some of these myths from when they come to your class and then at the end of the term?
I don't. I would need to do that to have some sort of survey of the class to begin with, and then a survey afterwards of that. And I don't do that, so I don't have any sort of direct evidence to whether what I'm doing seems to make sense to the students and perhaps changing their mind. That's a difficult thing to assess. And I kind of think in terms of the long game, I'm not expecting it to be in one semester. I'm really expecting these ideas, the principles of skepticism, requirement of evidence, to be sort of laying those seeds. Maybe years later, they're going to start thinking like, yeah, is there really the evidence for these crystals? Is there really the evidence for this dilution thing? And maybe, eventually they need to come to it on their own. That's really the only way. As Socrates is saying, you can only make them think through challenging questions. You can't really change someone's mind. They need to come to it to themselves over the course of time, and I think a semester is maybe too short of a time period for that. Sort of think of it like therapy. You come in after years of therapy, you finally come to a realization, doctor, nobody likes me because I'm an asshole. And the doctor's like, yeah, okay, finally you figure it out after all these years. Like, what are you talking about? I knew that, the first 5 minutes of you coming in here, Steve, like, what? Why didn't you tell me? It's like, I didn't tell you because you weren't ready to hear it. So it takes time for that to mature. Who knows? Maybe there are some students who have their minds open to that. I would like to think so. Again, some things you don't want to know. Is it really working? I wonder. Yeah.
This is kind of a unformed thought, maybe, that I've been having.
Okay, those are the only kind of thoughts I have.
Good. In 8th grade, I had a wonderful teacher who, in retrospect, was a true skeptic. He kept advocating that people go look at things themselves. He used to tell, how do you know that Russia exists? You should go
there. Yeah,
see it,
right. Okay.
And one of the things that got me thinking about is that don't you need to teach students how to learn who to trust? Because to have students actually discover everything for themselves is almost counterproductive to education, right? You want to teach students how to learn, you want to teach students how to trust, but part of the reason that we're going to school so that we can kind of earn the knowledge that we've amassed on the planet so far and then take that to another level, right?
Yeah.
How do you teach students how to learn who to trust, I guess? Because at some point, I'm going to take somebody's word for something.
I think it is true that with certain things, kind of fundamental physics concepts, for instance, it makes sense to read that out of a textbook and say, okay, force equals mass times acceleration. You can show that in the lab happening. You can use that. That is probably a good way of thinking about the world, and not have to recreate everything for scratch from each student. Now, in terms of a question like, is there a Russia? That sort of thing. Like, you can pretty much imagine there is a Russia. Maybe at some point you'll be able to verify and actually go there. But some things you should, probably take on just what the textbook and the teacher says. Some things, but other things I think definitely do need to be personally experienced. Do need to have that. And I think so. The answer to your question might be it really depends on what that thing is. Generally, I try and tell my students, don't trust me. I'm wrong more than I'd like to admit. And so, with the Russian phrase, trust but verify could be thrown in here.
Is it on? Yeah. First, a picture of Socrates drinking hemlock is not very encouraging to an educator.
I don't know. I think it kind of is. He said, he lived to 70. He was like, I'm not going into exile. No. One of his followers said, I'll finance you. I'll set you up.
That's not old. All right.
Okay. At this time period, that was a very mature life. So, Socrates basically chose to die. Who wrote that great book on the trial of Socrates? I forget. Basically, he had other options. He says, screw you guys. You guys are going to convict me. Screw you. My name will live on forever. And so, I think it might be encouraging.
Okay, my other problem is with people who are supposedly educated, being the source of information for students, because they have a PhD or MD, any kind of thing that identifies them as Dr. So-and-so. And so you get people like Michael Behe. Doctor of chemistry, and he really believes what he says. And you get these people in academia, amongst the students and amongst the professors. Some may be actually teaching teachers. There are schools in which that happens. And then these teachers go out and they're supposed to be teaching in high school or grammar school. My fixation has been the problem in academia of non-science, of anti-science in academia. I think that's got to be solved if the whole process of training teachers is going to be maintained. It's going to be improved to the point where they can be depended on to have technique and a background to be able to teach these things.
Well, you said something very interesting at the start there, is the idea of academics, of professors as sources of information. And I would maybe think that's maybe not the way I would approach it. I would think there's sources of questions. There's sources of people who know enough about it to ask the really pertinent questions that will lead students in a certain direction. So with Michael Behe, when I was working at NCSC, I corresponded with a student.
You might mention that Michael Behe is one of the major spokespeople for the intelligent design movement.
Yes, exactly. So Michael Behe is a professor at Lehigh University and wrote a couple books, Darwin's Black Box, and really sort of comes with academic credentials. He teaches biochemistry, and he's a tenured professor. So I corresponded with a student who was taking his class at Lehigh, and the student was kind of telling me, well, we covered this week, no intelligent design mentioned. Covered this next week, these types of bonds, no intelligent design. So Michael Behe taught that one class pretty straight chemistry, for what it's worth. So he wasn't interjecting that into there and was being sort of a normal professor for that information.
Okay, we have time for one more question.
What do you think is the major source, the principal source? I teach American history. I used to say that it was politicians and Hollywood. I'm beginning to think it's now the internet. Because if people see a story on the internet and they say, oh, there's 1,200 websites that say this, they think it's... Has anybody heard of the Finland hoax? I just heard this today.
that Finland doesn't exist, it's a hoax. There are thousands of websites. It's out there. There are thousands. Has anybody heard this, that Finland doesn't exist?
Has anyone ever been to Finland?
Yeah.
Oh, okay, whatever, there you go. All right.
There are thousands of websites that claim
You're
it
from
doesn't exist. That seems to,
Yeah.
So what's the main, what would you say is the principal source?
Well, I don't know, in this modern era, things have really changed. I actually got my first degree in European history, so I kind of sympathize with teaching American history on that. I think students today approach it that if you can't Google it, it doesn't exist. And so that's where their information is coming from. As historians, we might remember the time when you're going into the deep archives of the library, taking out books that have an inch of dust on them, and you realize that 99% of the history of the information is not digitized, it's not on the internet. There's a whole wealth of things outside of that. It sort of makes me shudder to think of somebody assuming you can Google every question, that little slice of knowledge is the whole sum of what we know. You ought to go into a library, dust off that dust on books and actually look at them, I think, and at least in terms of history. So yeah, it is a troubling thing. I don't know how to get around that other than to, I don't know, randomly shut off the power and not have students able to Google things and they have to start looking it up elsewhere. And they go, hey, wait, Google didn't say that.
If you want an answer to that question, really, I recommend you read Kurt Anderson's Fantasyland.
Kurt Anderson's Fantasyland? Fantasy.
Yeah.
Fantasyland.
It's a not very normal history of America.
Yeah.
And it directly answers that gentleman's question
about
why we're here today. And I think it's an excellent piece of writing. Kurt Anderson's Fantasyland.
Thank you for that recommendation. And speaking of recommendations, I recommend that you join us in November on the second Thursday of the month, which I believe is November 14th, for Achille Erican, one of the other Bay Area Skeptics board members, who will be speaking about international skepticism. She is a leader of the Turkish skeptical movement and has had some extremely interesting experiences dealing with skepticism in her of people from her native land.
Isn't November exploratorium?
No, that's his extra.
Oh.
We have a regular SkepTalk and then there's the exploratorium. Anyway, thank you very much for coming to this month's SkepTalk.